Hey pre-calc. In this video I am going to be showing you synthetic division and the remainder theorem. So you can title your notes 2-3 Day 2 Synthetic Division and Remainder Theorem. Pretty to the point. So synthetic division is new for you guys. You did not learn it in Algebra 2. At least not at Skyline. So synthetic division is a shortcut for dividing a polynomial by a linear factor of the form x minus c. So synthetic division is nice when you're dividing by a linear factor. You can't use it if it's not a linear factor, so if you're dividing by a cubic or a quadratic or really any other type of polynomial, it's just not going to work. But it works for linear and it's quick, so that's really nice. So this is how it works. So we're going to divide using synthetic division. We're going to divide 2x to the fourth minus 5x squared plus 5x minus 2. So divide this by x plus 2. So, where's my, there it is. Okay, so this is like our x, this is our x minus c. Okay, so we set up synthetic division as follows. With the coefficients of the polynomial in the top row. Include placeholders. So placeholder, if you look here, we've got 2x to the fourth and it jumps to 5x squared, so we need a placeholder for the x cubed. That is one of the biggest mistakes students make. So let's get to it. So we've got 2, 0, negative 5, right, 4, 3, 2, 1. So negative 5, positive 5, negative 2. Okay. And then to the left of that row, you have your c value. Now be careful, it's just c, so because this is x minus c, that means our c value here is going to be negative 2. So we put negative 2 to the left, and we kind of put it in this little box to show that this is c. So here's our c, here are all of our leading coefficients, and a placeholder. So what you do is you bring the first number down. We have like a bar, if you will. And when we go down, the first one just comes right down. So we start with that leading coefficient of 2. And then what we do is we multiply by c to get a number right here. So do 2 times negative 2, which is negative 4. And then we add. So when you go to get your number here, you're multiplying by c, and then here you just add going down. So 0 plus negative 4 is negative 4. And then we multiply by 2, so negative 4 times negative 2 is 8. And then we add going down, so negative 5 plus 8. Multiply by c, so 3 times negative 2 is negative 6. And then we add, so 5 plus negative 6 is negative 1. Multiply, negative 1 times negative 2 is 2. And then we add. We get 0. Alright, so I like to put a little box here too, because the last number you get, this is going to be your remainder. So when you go down, it means you're adding, and then your arrow going across is multiplied by c. Okay. These numbers are the coefficients of your depressed polynomial. So our conclusion is 2x to the fourth minus 5x squared plus 5x minus 2 divided by x plus 2 simplifies to b, and then we just use these. These are the coefficients. So it's going to be 2, and then if this is our constant, this will be x squared, x cubed. So this will be 2x cubed minus 4x squared plus 3x minus 1. And because the remainder is 0, that means that this is actually a factor. X minus 2 is a factor. So we don't need to do like plus the remainder over what we were dividing by. So that's it. This is our final answer. And everything here is required work. So you need to have this whole thing, and then you need to have your conclusion of what it divides to equal to. So synthetic division is nice because it's a little bit quicker. And then what's really cool is we got the remainder theorem. So the remainder theorem indicates that to evaluate a polynomial, f of x for x equals c. So basically, what is f of c? You can divide f of x by x minus c using synthetic division and the remainder will be f of c. So the remainder theorem will be f of c. So using synthetic division, to evaluate a function is called synthetic substitution. Okay, so let's do an example. We'll have find f of c using synthetic substitution. And let's do f of x equals 4x to the fourth plus 21x cubed plus 25x squared minus 5x plus 3. And let's have c equal 1. So essentially what we're doing is we are just doing f of 1, but we do want you to be using substitution. Synthetic substitution. So remember to set it up. We're going to put c in the left, so 1. And this time we were given c just like as is, so we don't have to like do the opposite. Where here it was plus 2, so c was negative 2. Okay. Then we write our coefficients, and it does go 4, 3, 2, 1, so we don't need any placeholders. So 4, 21, 25, negative 5, and 3. So the first thing we do is bring down that 4, and then we have a bar here, and our remainder will be what's left. So 4 comes straight down. 4 times 1 is 4. So remember here we multiply, here we add. So 21 plus 4 is 25. Times 1 is 25. 25 plus 25 is 50. Negative 5 plus 50 is 45. 45 times 1 is 45. And 3 plus 45 is 48. So since this is a remainder, the remainder theorem says that the remainder is what f of c is. So then our final answer is f of 1 is equal to 48. And that's it.